just a little subtlety to know. So now let's have a look in the console to see how CNAMEs and alias records work. So let's go. And alias records work. So let's go ahead and create a record, and this one will be of type CNAME. So I will call this one myapp.stefan.teacher.com, and the record type now is not A, it's not quadruple A, it's CNAME, and then the value must be a domain name. And very easy, I already have a domain name available, that's my ALB. So what I'm going to do is that I'm going to copy the hostname of my ALB and paste it in here. The idea is that now instead of accessing my ALB through this URL, I want to be access the ALB through myapp.stefan.teacher.com. Okay, so I will just create this record, and now myapp.stefan.teacher.com has been created. And so if I go into my Chrome web browser on the right hand side and open this URL, now you see that the answer is hello world from my IP, blah, 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 in AZ EU Central 1C. So this domain name is in fact covered by the ALB, and the ALB is directing the traffic into one EC2 instance, and so therefore I receive back this hello world. So this is good, but this is not AWS native, okay? This is something that will work for many domain names, but we can do something better because we are redirecting into an ALB. What we can do is create an alias record. So I can create a record, and this time is going to be myalias.stefan.teacher.com, and the record type is A, because my ALB is currently having only IPv4 traffic, and the value of it, so we have to tick the alias right here, and we're going to route traffic to, and then we have a list of options, okay? So as we can see, a lot of different options, but right now it's going to be an alias to an application and classic load balancer. We need to choose a region, so it is in EU Central 1 for me, and then we need to choose the load balancer, so I will choose this load balancer right here. Then automatically we can evaluate the target health as well with a yes, because this is an alias record. So we'll click on create this record, and now I have a new record right here called myalias.stefan.teacher.com. And the cool thing is that this record is free to query. Okay, so I'm not going to pay any money because this is an alias record. So if I click on myalias.stefan.teacher.com, it's going to perform a few DNS queries, and now again I get the same response. Again, nothing has changed, but it is working. Okay, so that's perfect. But now what if we consider the domain apex? So if we want to have just stefan.teacher.com to redirect to this page. So what we're going to do is create a record. And let's go ahead. So we're going to just have nothing in here, okay? And we're going to have a CNAME record pointing to the domain name of my ALB, which is copied from here and pasted in here. Okay. So we want to say, hey, stefan.teacher.com is going to be a CNAME for this value. Now this is not going to work. Let's try it. It's saying, hey, bad request. The CNAME is not permitted at apex of this zone. So this zone is stefan.teacher.com, and the apex of the zone is stefan.teacher.com, and therefore we cannot set up a CNAME at the apex. So the only way we can deal with this issue is instead to create an alias, and the record is going to be of type A, and the alias is going to point again to an ALB or CLB in the EU Central 1 region, and the load balancer is going to be the one from before. Now this is going to be accepted because this is an alias record, and this is what the exam may test you on, okay? And so now we can see that stefan.teacher.com is accessible. And so if I go back into my web browser in here, open a new tab and enter stefan.teacher.com and press enter, here I get back the hello world from my load balancer. So everything is working great. So that's it. We've shown how CNAMEs and alias records work in AWS. I hope you liked it, and I will see you in the next lecture. So now let's talk about routing policies for Route 53. So a routing policy is helping Route 53 respond to DNS queries, and we shouldn't be confused about the word routing, okay? This is not like when you have a load balancer and the actual load balancer will route traffic to the backend EC2 instances. No, no, no. This routing is from a DNS perspective, so the DNS does not route any traffic, so the traffic doesn't go through the DNS. The DNS only will respond to the DNS queries, and then the clients will know to which way they should be doing these HTTP queries, for example, okay? So the DNS just helps translate host names into actual endpoints that the clients can use. Okay, so Route 53 will support the following routing policy. There's simple, weighted, failover, latency-based, geolocation, multi-value answer, and geoproximity. And we're going to have a look at all of them in this section, okay? So the first one is going to be the simple routing policy. And the idea is that that we've actually been using before, we're going to route traffic to a single resource typically. So here's an example. The client will say, hey, I want to go to foo.example.com. And Route 53 will say, hey, go to this IP address. And this is an A record. So it is possible for us to specify multiple values in the same record. And if multiple values are returned by the DNS, then a random one will be chosen by the client or client side. So in this example, we have the clients asking again for foo.example.com, and Amazon Route 53 will just reply with 3 IP addresses that are embedded into the A record, and then the client will pick one of them randomly and apply it for the routing. So if you have enabled an alias record alongside the simple policy, then you can only specify one AWS resource as a target. And finally, it's called simple because it's very simple, and therefore you cannot associate this with health checks, and we'll see health checks later on in the section and how they work, okay? So let's go in the console to see how a routing policy of type simple can be created. So let's create a record, and the record name is going to be simple.stefan.teacher.com. It's an A record, and the value of which is going to be, for example, my instance in AP Southeast 1. Now for TTL, I will set something very low, like 20 seconds, and the routing policy is going to be here. So as you can see, we have different possibilities. 6 of them, and then one other. that is somewhere else in the UI. So we have a TTL 20 seconds, a simple routing policy, and let's just create this record. So we've been doing this before. We know how this works. So now if we go to simple.stefano.t-shirt.com and go to this URL, we get hello world from my instance in AP Southeast 1B, which is awesome. And if we do a dig command and have a look, so we need to reinstall dig. So sudo yum install util. So this is because I restarted my machine here. Okay, so we're going to redo the dig command. So we do the dig command on this. As we can see, we have an A record of a TTL of 20 seconds pointing to this IP. But we can change this record now. We're going to edit the record. So I will just simply click on it and edit the record. And for the value now, I can enter multiple IPs. So I can enter my one in AP Southeast 1 or one in US East 1, for example. So when I do so and save this, what's going to happen is that once the TTL expires from before, we're going to get 2 records back. So let's use Cloud Shell to verify this. So I'm going to do a dig command. And as you can see, now we have in the answer section, we have 2 responses. We have one in this IP and one in this IP. So it's a client-side choice. So that means that if I go to this website and refresh, I have 1 chance out of 2 to go into US East 1, and I didn't. So I was back into AP Southeast 1B, but let me pause for 20 seconds and I'll get back to you. And I'm refreshing, and I get back the hello world from US East 1A. So this worked. This absolutely shows how simple records work. I hope you liked it, and I will see you in the next lecture. So now let's talk about the weighted routing policy. The idea is that you can have a percentage of requests you can control to go to a specific resource thanks to weights. So put it simply in the diagram, we have Amazon Route 53, and then we have 3 EC2 instances that have been assigned different weights. So 70, 20, and 10. In my example, these weights sum up to 100, but you don't have to in the real life, okay? But what this means is that 70% of the DNS responses from Amazon Route 53 are going to be redirecting to the first EC2 instance, then 20% to the second, and 10% to the third. So what we have to do in our way is to assign each record a relative weight. And then the traffic percentage is going to be sent to each record is just the weight of the record divided by the sum of all the weights of all the records, which is like a percentage of all the weights, okay? The weights don't need to sum up to 100. They're just indicative of how much we want to send to this instance compared to all the other records in your DNS name. So to make this work, the DNS records must have the same name and type, and you can associate them with health checks, although we haven't seen what health checks are again yet, but we'll have a look at them very, very soon. Now, the use cases for a weighted routing policy is pretty obvious, is to do, for example, load balancing, maybe across different regions, or to test a new application version by sending a small amount of traffic to it, and so on. And then if you assign a weight of 0, then you're going to stop sending traffic to a specific resource, so you can shift weight over time. And if all the resource records will have a weight of 0, then all the records will be returned with equal weights. So let's have a look in the console to see how that works. So let's create a new record, and this one is going to be called weighted.stefan.teacher.com. It's an A record, and the routing policy is going to be weighted. So first, for the first value, let's
Seems like some ever-changing illustration.
Enter the one from AP Southeast 1. And the weight I'm going to assign to it this time is going to be 10. Okay, so a very, very small weight. For the TTL, I'm going to set it to something really low, 3 seconds, to just show you the impact of weighted. But obviously, this is not a TTL you would use in real life. So as we can see, we can associate a health check with it, but for now we won't. And we have a record ID that we can set. And this is to identify this specific record within the weighted record sets. So for this one, I got this instance from the Southeast, so I'm just going to write Southeast. Okay. And then we can add another record. And again, we're going to use the same weighted.stefan.teacher.com. Okay. And the routing policy is going to be weighted. And the value of which is going to be the one from US East 1. So I'm going to copy this IP and paste it here. The weight is going to be on this time 70. So we're going to send 70% of the traffic to US East 1. And then the record ID is US East. Great. And the TTL, again, 3 seconds. And one last record we're going to add. So again, weighted. And then the value of which is going to be EU Central 1 in here. And I'm going to send it as a weighted record. I'm going to send 20 as a weight. And the record ID is going to be EU. Okay. And the TTL, 3 seconds. So now let's go ahead and create these records. And as we can see, we now have 3 records in this table. Okay. So this is why it's different from, for example, a simple record that had 2 values. Here we have 3 records, and each record has 1 value as an answer. But we have a weight of 10, 20, and 70. So if I go to the URL now, if I go to weighted.stefan.theteacher.com and press enter, I'm getting a first response from US East 1A, which makes sense because, well, this is where 70% of the traffic is supposed to be going, okay, to this region. But if I refresh, and I need to refresh maybe every 3 seconds, at some point, I should be getting a response from another region. And this is just based on weight. So this is the whole idea behind weighted resources. So as you can see, this one is not changing a lot. So let's do a dig command just to show you the output of what it is. So dig weighted.stefan.theteacher.com. And here we get a TTL of 3, and the answer is, I think, still the one from US East 1. But so let's try to issue one more and see if we get any luckier. So the weight of 70 definitely is a big weight. Okay, but here, as we can see, we just got an answer, and this one is a different IP, 3.70.14, which is corresponding to the weight of 20. So as you can see, weighted does exactly what it's supposed to do. It's redirecting most of the queries into the one that has the most weight, but from time to time, you will get other answers, okay? And so on. So this is something you can practice in your web browser as well. As you can see, cool, I just got redirected into EU Central 1C. So that's it for this lecture, and hopefully it shows you the power of weighted records. I hope you liked it, and I will see you in the next lecture. So let's talk about a routing policy that's super easy to understand, which is the latency-based routing policy. Okay, so now let's talk about latency-based routing policies. And the idea is that you want to redirect to the resource that is going to have the lowest latency, so the closest to us, which is super helpful when latency is your main concern for your websites or applications. Now, latency is going to be measured based on how quick it is for users to connect to the closest identified ALS region for that record. So for example, if you're in Germany and you have the lowest latency to a resource in the US, then this is where you'll be redirected. And this can be combined with health checks that we'll see in the very next lecture. So let's have a look at the map of the world to understand it. Say we deploy our applications in two different parts of the world, one in US East 1 and one in AP Southeast 1. Then the users are all around the world, and the latency is going to be evaluated by route 53. And so the users closest and with the lowest latency to the ALB in US East 1 will be redirected there, whereas the other users will be redirected to AP Southeast 1. Now let's put this into practice in the console. So let's create new records, and the record name is going to be latency.stefan.com. And the first value is going to be the one in AP Southeast 1. So I'm going to paste the value in here. And then the routing policy is going to be latency. So when we do this thing, because we just put an IP address in here, we need to specify the region of our record. So this one is going to be corresponding to AP Southeast 1, which is Singapore, okay? And the reason is that AWS is not smart enough, at least in this stage, to take this IP and know that it comes from an EC2 instance that I have in Singapore, because it could be any IP in the world, actually. So it's for us to specify, hey, this IP corresponds to the region Asia Pacific, Singapore. And then we can associate a health check and a record ID. So I'll call this one AP Southeast 1. And it's just a name that I give it. Now we can add another record. Again, the record name is going to be latency, and the value of which, this one, is going to be for US East 1. So I'll have the value here, and it's going to be weighted. No, latency, excuse me, of course. Then it's US East 1. And again, I will just have it as US East 1 for my record ID. And then one last record is going to be for EU Central 1. So I will copy this IP. And the record name is this. The value is here. The routing policy is latency. And the region is EU Central 1. So will be the name. Okay, so as we can see, we have 3 records being created, successfully created. And they sit right here. And so now let's try them out. So right now I'm in Europe. And so if I open this, I'm expecting it to go to my instance in Europe. So I go to this URL and I get a response hello world from this IP in EU Central 1C. If I use Cloud Shell to try it out and we do a dig command on this, as we can see, we get an A record back of just one value. Okay, so just one value of the same IP address as this one. So this is my instance in EU Central 1C. And if I keep on refreshing, well, because my latency hasn't changed to EU Central 1, I'm going to get always the same answer, okay? But how do we test whether or not the latency record is working? Well, for this, I can use a VPN. And so let's go to Canada, for example. And in Canada, well, it turns out that my latency is going to be the closest to the US. So if I refresh this page now, I get the hello world from the US. And when I did change my location thanks to the VPN, it cleared all the TTL that I had for my DNS cache locally on my laptop. And so this is why automatically by refreshing it, I was able to get the newest value for US East 1A. But again, if I use dig, because this hasn't changed, okay, my Cloud Shell is still in Europe. Okay, if I use the dig command and use the exact same command as here, I'm still going to get the exact same value as before, okay? Because, well, this computer right here, this Cloud Shell, sits in EU Central 1, and so this is still the closest location to EU Central 1. And how do we test the one for AP Southeast? Let's go into Hong Kong. Okay, so I'm close to Singapore now, and I will refresh this. And the answer is hello world from AP Southeast 1B. So the latencies record are working, and they're really, really good and very common to use online. I hope you liked it, and I will see you in the next lecture. So let's talk about health checks in Route 53. So health checks are a way for you to check the health of mainly public resources, although there's a way for us to do it for private resources as well, as we'll see in this lecture. So the idea is that, for example, we have 2 load balancers in different regions, and they're public load balancers, okay? And behind the scenes, we have our application running in both of them. So we're running into a multi-region setup because we want high availability and so on at the region level. Then we're going to use Route 53 to create DNS records so that when users access our URL, for example, mydomain.com, then they get redirected to, for example, the closest load balancer they have. So this would be the case with a latency type of record. But we want to make sure that if one region is down, then we don't send our users to that region, obviously, right? So to do so, we're going to create health checks from Route 53. So we'll create a health checks on the one in US East 1, and we will create a health check on our instance in EU West 1. Well, with these 2 health checks, we're going to be able to associate them with our Route 53 records. And the reason we do so is to get automated DNS failover. So we have 3 health checks that are possible. The ones I just showed you, which are the health checks that monitor an endpoint, which is a public endpoint. So it could be an application, a server, or another AWS resource. It could be a health check that monitors other health checks, also called a calculated health check. Or it could be a health check that monitors a CloudWatch alarm, which gives you more control and is helpful for private resources, as we'll see in this lecture. Finally, these health checks have their own metric, and you can view them in CloudWatch metrics as well. So let's look at how health checks work with a specific endpoint. So if we have a health check for EUS1, for an ALB, then the health checkers of AWS are coming from all around the world. So it's not just one health checker, it's about 15 health checkers from all around the world. And they're all going to send requests into our public endpoint to wherever route we set. And then if it gets 200 OK code back, or the code we defined, then the resource is deemed healthy. So about 15 global health checkers will check the endpoint health. And then you can set a threshold for healthy or unhealthy. You can set an interval. So we have two options. It could be either 30 seconds for regular health checks or every 10 seconds, which is a higher cost, which is what's called a fast health check. It supports many protocols, so HTTP, HTTPS, and TCP. And the rule is that if over 18% of the health checkers say that the endpoint is healthy, then Route 53 will consider it healthy. Otherwise, it's deemed unhealthy. And you have the ability to choose which locations you want to use for the health checks. Now, the health checks will only pass if you have the status 2XX or 3XX status code back from the load balancer. And the health check has a cool capability. So if it is a text-based response, then the health checkers can check the first 5,120 bytes of the response to look for some specific text in the response itself. Finally, very important from a network perspective, if you want for it to work, obviously, the health checkers must be able to access your application balancer or whatever endpoint you have. And so therefore, you must allow incoming requests coming from the Route 53 health checkers IP address range. And you can find this address range at the URL in the bottom right of the screen. Now, the second type of health checks we have are calculated health checks. And so this is to combine the results of multiple health checks into a single health check. And so if we look at Route 53, with 3 EC2 instances, we can create 3 health checks. They're all going to be children health check, and they can all monitor each EC2 instance one by one. And then we can define a parent health check, which is going to be defined on all these child health checks. And so the conditions to combine all these health checks could be an or, an and, or a not. You can monitor up to 256 child health checks, and you can specify how many of the health checks need to pass to make the parent pass. So the use case for this would be to, for example, if you want to have a parent health check to perform maintenance on your website without causing all the health checks to fail. And so how do we monitor the health of a private resource? So in case you want to monitor something private, it's going to be difficult because, well, all the Route 53 health checkers live on the public web and they're outside of your VPC. So they cannot access private endpoints. So if it's a private VPC or an on-premises resource. And so the way we can do it, though, is to create a CloudWatch metric and assign a CloudWatch alarm on it. And then you can assign the CloudWatch alarm into the health checker. So the idea is that we're going to monitor the health of our EC2 instance in a private subnet with a CloudWatch metric. And then if the metric is breached, we're going to create a CloudWatch alarm on it. And when the alarm goes into the alarm state, then the health checker is going to be automatically unhealthy. And therefore, we'll have created exactly what we want, which is a health check on a private resource, which is the most common use case on how to do it. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So let's go ahead and create some health checks. So on the left-hand side, I'm going to go into the health checks, and we're going to create health checks for all our EC2 instances. So we're going to create 3 health checks. So the first one is going to be for my instance in US East 1, and it's going to be an endpoint. And then you need to specify either an IP address or a domain name. So we'll keep it as an IP address. And my instance in US East 1 is right here. So I will paste that in. We have to specify a port. So we'll keep it as 80 because this is the HTTP port. And for path, we're just going to be keeping the path as / because, well, this is the same as the IP /, which is the root of our website. If we had a real application, sometimes it is very common to have a path /health, for example, which responds with the health of the endpoint itself. Okay, so we have this ready. So I will just remove the /health. And then we can look at some advanced configurations. So we can have either a standard every 30 seconds or a fast every 10-second type of health check. We'll keep it as standard because this is otherwise more expensive. How many times it needs to fail before being considered as a failure? Do you want to do string magic? So do you want to look for a string in the first 5,120 bytes? Yes or no? Do we want latency graphs? So to see whether or not, to get to see how latency evolves over time. Do we want to invert the health checkers? So do you want a healthy to be unhealthy and vice versa, or disable it? And then do you want to customize the regions of the health checkers, or do you want to use a recommended? And we'll just keep it as is with using recommended. So every option is pretty much as default. And do we want to be notified whenever this health check fails, yes or no, by creating an alarm? I will just say no for now. So we have created our first health check. Now let's create our second health check. And it's going to be for AP Southeast 1. So AP Southeast 1. And then IP address right here, not host name. And then next and create. And the last health check is for EU Central 1. So let's create this health check. And I will name it EU Central 1. And then here is the IP address. And click on next and create health check. Okay, so our health checks are now created. And what I'm going to do is that I'm going to go to one of my instances, for example, the one in Singapore. And for the security group, I'm going to start blocking the port 80, removing this rule. And the idea is that I want to get a failing health check. So I'm going to go into the security group right here. I will do action and edit the inbound rules. And I will delete my HTTP-based rules. And what this will do is that the one health check for AP Southeast 1 should give me a unhealthy status. So let me wait a little bit for the health checkers to do their thing, and I will get back to you. Okay, so as we can see, we have 3 health checkers, and one of them is unhealthy, obviously, because I locked the security group, and the other 2 are healthy because I didn't change the security group of them. So we can have a look at the health checkers, and they give you some information around when it was last checked and so on. And for the unhealthy one, we can view the error status. So if we look at view last failed check, we can see that there was a connection timeout and maybe the requests are being blocked by my firewall, and firewall is your security group. So that makes sense. So at least it gives us some information, and they are working just as expected. And one last thing that you can create is a create a health check. And this one is going to be a calculated health check. Calculated, here we go. And the is going to check for the status of other health checks. And now we can specify with which health checks we want to monitor. And okay, we're saying maybe you want to report healthy when one of the three health checks are healthy, or when two, or when all of them are healthy. So this is an and, or one or more health checks are healthy. So this is an or. So we can definitely create a complicated rule. So I will just keep it as this should be healthy when all my health checks are healthy. And then click on next, next, and we have created a calculated health check. And the last kind of a health check we can create is to monitor the state of a CloudWatch alarm, in which case we need to specify the region the alarm is going to be in. And then this alarm could be monitoring, obviously, the state of a private EC2 instance, for example. And this is how we would link the health check, the health of a private resource into a Route 53 health checks, okay? But I can't create right now because I don't have an alarm available for us, okay? Okay, so my calculated health check is now reported unhealthy because, well, one of the health checks I'm trying to monitor is unhealthy, and this is how we define it. So that really shows you the power of health checks, and in the next lecture, we'll be using them, of course, alongside records in Route 53. So I hope you like this lecture, and I will see you in the next lecture. Okay, so now let's talk about routing policies, and this one is going to be for the failover. So the idea is that we have Route 53 in the middle, and we have two EC2 instances. One is going to be our primary EC2 instance, and the second one is going to be a secondary or disaster recovery EC2 instance. In this case, what's going to happen is that we're going to associate our primary record with a health check, and this is mandatory. And if the health check becomes unhealthy, then Route 53 is going to automatically fail over to the second EC2 instance and start sending that result back instead. And of course, the secondary EC2 instance can also be associated with a health check as well if we wanted to. But they can only be one primary and one secondary. Now, the clients, when it makes DNS requests, will automatically get the resource that is deemed healthy. So if our primary is healthy, then Route 53 will answer with a primary record. But if the health check is unhealthy, automatically we will get the response of the second record, which really helps us do actually a failover. So that's it. Let's go in the hands-on to see how we can practice this. Okay, so now let's leverage these health checks and create a failover record. So in my hosted zone, I'm going to create a record, and this one is going to be called failover.stephantheteacher.com, and it's an A record, and the first value is going to be for my EU Central 1 instance, so the one close to me, and the routing policy is going to be a failover. So the TTL, I will set it something really low, like 60 seconds, and the failover record type has two options. It could be either primary or secondary, just these two. So this is my primary record, and I will associate it with a health check. I have to. So I will associate with my health check named EU Central 1, and the record ID is going to be EU. So what this is saying is that this record should be my primary one, but this is going to be associated with a health check, which means that you can fail over to a second record. So let's add a new record, and we'll keep the record name as failover.stephantheteacher.com, and the value of which is going to be my instance in US East 1. Okay, we're still going to have to do a failover. The TTL is 60 seconds, and the failover record type is going to be secondary. Now we can optionally associate a health check with it, okay, of US East 1, but you don't have to, and the record ID is going to be US. Now let's create this record, and now it was successfully created. And so let's go back into our health checks, and currently these two health checks I've associated with my records are healthy. So if I go into the URL, so if I go to failover.stephantheteacher.com, right now I get an answer from EU Central 1C. That's perfect. But what I'm going to do is trigger a failure. So let's go into the EU Central 1 region, and I'm going to find my instances here, and I'm going to find the security group, and I'm going to, again, stop some security group roles. So let's refresh this page. It does exist. That's perfect. And for the inbound rule, I'm going to edit it, and I will remove the rule on port 80. So that will make my instance completely unreachable from the health checkers. So what I have to do now is to wait for this health check to become unhealthy, and then we'll be able to test the failover. So let's refresh, And as we can see now, my EU Central 1 health check is deemed unhealthy. And we can look in the monitoring tab and see really when it got unhealthy. So this is quite cool. So the health checker was positive and then it went to 0. And then we can see how many percentage of the health checkers did report healthy. And again, this went down to 0. So what this means is that now that this health check is unhealthy, because of the way we set up the failover, that it was linked to this health check, then next time I refresh this, I should not be in EU Central 1C, I should be in US East 1. So let's refresh this parent page. And yes, the answer is that we are in US East 1. And so the failover did work seamlessly behind the scenes. And well, to fix it, you just go back into your security group, you would edit the inbound rule, and then you would add back the HTTP rule, and then automatically the health check is going to pass again, and therefore we are going to fail over back to our primary location. Okay, so that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about the routing policy geolocation, which is very different from latency-based. So this is based on where the user is actually located. So for example, you can say if a user comes from a specific continent or a country, or even more precise on the US state, and the most precise location is going to be selected at first, then route to this IP. So you should create a default record in case there's going to be no match on location. And the use case for this is going to be for website localization, to restrict content distribution, do load balancing, and so on. And these type of records can be associated with health checks. So the idea is that if we have a map of Europe with multiple countries, we can define a geolocation record for Germany to say that German users should go to this IP, which contains my German version of my app. And if I go to France, then go to this IP, which contains the French version of my app. But for anywhere else, go to the default IP here, which contains maybe the English version of my app. So this is how you would use a geolocation. Now let's go practice in the console. Okay, so let's go ahead and create our first geo record. So I'm going to create a record, and I'll name it geo. And the record type is going to be A. The value of it is, let's link it first to the AP Southeast 1. And what we're going to do here is going to say the routing policy is going to be geolocation. And we're saying, okay, all of Asia, so any user located in Asia should go to my AP Southeast 1 EC2 instance. We could associate a health check with it if we wanted to. We need to give a record ID. So here we go. Now let's add another 2 records. So what I'm going to do is that I'm going to say that for US East 1, I want to send any user from, and we can say geolocation yet again. And let's say, for example, just a country. So we can say United States. And we could say lastly, so this is record ID, US. And so as you can see here, I specified a country, and here I specified a whole continent. It doesn't matter. And then lastly, I will add one more record. Here's the record name, and the value of which is going to be EU Central 1. And this one is going to be my default. So I'm going to say geolocation, and the location is default. That means that anything that doesn't match Asia or United States is going to go to my default location, and this one is going to be called default EU. Now let's create these records, and they've been successfully created. So what I can do now is that I can test it, right? So currently I am not in the US and I'm not in Asia. So if I open this URL, I will get the EU Central 1 region. So this is good. That means that this is the default record that is pure, that is working properly. So now let's change geographic location. And to do so, I'm going to use my VPN. And now let's go to a country in Asia. So let's go to India. So I'm now connected into India. And when I refresh this page, now what I expect is to get a hello world from my AP Southeast 1 instance. Oh, as you can see, there's a long load. So I know what's happening. So this is a timeout. And so whenever you see a timeout in AWS, usually you have to think about security groups. So if I go to my security group, yes, I'm in the right region. So in the Singapore region, and look at the inbound rules and edit them. If you remember, I had removed the HTTP rule to make the health check fail. So we need to add back that HTTP rule. So let's add it back. And it's a good error to have on screen. So the HTTP rule has been added back. And so now if I go back into this page, as we can see now, we get the hello world from AP Southeast 1B. So the Asia thing is working. Now if I go to a country in the US, so if I go to the United States overall, and I'm in the US and refresh, I'm going to get hello world from US East 1A. So this is perfect. And if I go to something right next to the US, but not in the US. For example, if I go to Mexico and refresh, as you can see, I get my EU Central 1C because this is my default record and the Mexico was not specified as a rule in the geolocation Route 53 record. Okay, so this is it. This is working perfectly. I hope you like this lecture and I will see you in the next lecture. So now let's talk about another feature, which is called geoproximity routing. And it can be a little bit confusing, but I will try to explain it with diagrams in the very next slide to make it clear. So this allows you to route traffic to your resources based on the geographic location of your users and resources. So the idea is that with this policy, you're able, using a number called the bias, to shift more traffic to resources based on specific locations. And I will show you this in a diagram in the very next slide. So the idea is that to change the size of a geographic location, you need to specify a bias value. If you want more traffic to go to a specific resource, you expand the bias value by increasing it. And if you want less traffic to go to a resource, you shrink it, you decrease the bias values to a negative number. So the resources can be resources from AWS, in which case you specify the region they're in and automatically AWS will compute the correct routing. Or if there are non-AWS resources, such as your on-premises data center, then you will just need to specify the latitude and longitude, such as AWS knows where they are right now. And then to use this feature, you need to use the advanced Route 53 traffic flow to be able to leverage the bias. So a diagram should make everything more simple. And to me, this is what you should remember. So let's take an example of a resource in US West 1 and one resource in US East 1. And the bias is set to 0 in both regions. So that means that if you have users all around the US trying to access these resources, sources, there's going to be a line dividing the US in two, and users left of that line will go to US West 1, and user right of that line will go to US East 1. Now this is simple. This is when there is no bias, okay? And this looks like going to the closest resource region based on the user location. But thanks to the bias, we can have the same setup, but a different way to have the user routed to different regions. So let's take an example. We have US West 1 and US East 1, and the bias is set to 0 in US West 1, but we're going to have a positive bias of 50 in US East 1. And we've seen that the bias makes more users and more traffic to that resource. Why? Well, because of the bias, now the quote-unquote dividing line between the two resources is going to be a little bit more to the left because of the higher bias of US East 1. And so what that means is that the user left of that line can go to US West 1, but the users right of that one will go to US East 1. So why would we do this? Well, for example, you would set your resources all around the world and say you needed to shift more traffic to a specific region. What you would do is that you would use a geo-proximity routing policy to increase the bias in that specific region and therefore have more users dragged and more users have traffic attracted to that region. So what you need to remember going into an exam is that the geo-proximity routing is really helpful when you need to shift traffic from one region to another by increasing the bias, okay? So hopefully the diagrams helped you make more sense of the geo-proximity routing policy. I hope you like this lecture, and I will see you in the next lecture. So now let's talk about another routing policy called the IP-based routing, which is very intuitive to think about because you're going to define the routing based on the client IP addresses. In Route 53, you're going to define a list of CIDRs. There are IP ranges for your clients, and you're going to say, based on the CIDR, which location the traffic should be sent to. So the use cases would be to optimize performance because you know the IP ahead of time, or to reduce network costs because you know where the IPs are coming from. So an example is that if you know that you have a specific internet provider and they are using a specific CIDR of IP addresses, you can route them to a specific endpoint thanks to this strategy. So let's go for an example. In Route 53, I'm going to define two locations with two different CIDR blocks. As you can see, one starts with 203 and the other one starts with 200. And they define IP ranges. Now we are going to link these locations to a specific record. So for example.com, we're going to have location 1, so the first CIDR block, to send to the value 1234, and the second location, the CIDR block number 2, to send to 5678. And these represents the public IP of two EC2 instances. Now, as you would expect, if a user comes in with a specific IP that is part of the location 1 CIDR block, they will be directed to the first EC2 instance of IP 1234, and the user B with a second IP address that belongs to the location 2 will be redirected and we'll have a DNS query response to the EC2 instance of IP 5678. And that's it for for IP-based routing. It's very simple, and I hope you liked it. I will see you in the next lecture. Let's talk about the last routing policy, which is multi-value, which is going to be used when you want to route traffic to multiple resources. And Route 53 will therefore return multiple values or resources. Now you can associate them with health checks, and so therefore the only resources returned by the multi-value policy are going to be the ones that are associated with a healthy health check. So up to 8 healthy records are going to be returned for each multi-value query. And although it looks like an ELB, it's not a substitute for having an ELB. The idea is that it's the client-side load balancing. So let's take an example. We are going to set up multiple A records for our example.com, and we associate them with health checks. So when a multi-value query is done by our clients, it's going to receive up to 8 records back, and then the client will choose one of them. But at least by combining this with health checks, we know that one of the 8 records is going to be the 8 records being returned, or up to 8 are going to be healthy, and therefore the client can have very safe queries into them. This is going to be different, for example, when you have a simple routing with multiple values in it, because as you know, the simple routing policy does not allow for health checks, and therefore it's possible that one of the resources returned in the query of a simple routing policy will be unhealthy. This is why multi-value are a little bit more powerful as types of records. So let's have a look in the UI at how we can test them. So let's practice the multi-value record. So let's go and create a multi-record. So a multi dot blah, blah, blah. And then the value of it is going to be linked to US East 1. So I will add this value here. And then the routing policy is going to be multi-value. The health check is going to be US East 1, and the record is going to be US. and the TTL is going to be 60 seconds. Let's add another record, so multi. And again, we're going to route to a different region. So this one is AP Southeast 1. So the answer is multi-value answer. The health check is AP Southeast 1. And the record ID is going to be Asia. And then the record TTL is 1 minute. And then finally, the last one. So again, one more record name. The value is going to be linked to EU Central 1 right here. The TTL is 1 minute. And the routing policy is multi-value answer. And for the health checks, we're going to use the one from EU Central 1. And the record ID is EU. Okay, so let's create these records. And the records are successfully created. Now let's test it out. So for this, we're going to use our Cloud Shell in here. So let's reconnect to Cloud Shell. And what I want to do is to test this record. So I will copy the record in here. And then I will clear my screen. And so if I test a dig on this, then I get 3 answers. So the 3 IPs are returned. And the reason is, well, the 3 health checks are fully working. So as you can see, they're all healthy. But if I take one of them, for example, I remove the EU Central 1. So I'm going to make this one unhealthy. And I'm just going to trick it by editing and do an invert health status. So this is going to make the healthy unhealthy and vice versa. It's just a quick way for me to create an unhealthy health check. So let me pause right now. Okay, so now my EU Central 1 health check is unhealthy. And so if I reissue a dig command right here, I should expect to see only 2 values yes as a result. So the multi-value answer has worked and it worked really well. So just to revert this, get this health check, and let's untick this invert health check status, and we're good to go. Okay, so that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So we need to make the distinction between a domain registration registrar and a DNS service. So actually, you can buy your domain name with any kind of domain registrar you want, and you're going to pay annual charges. So the way we did it so far in this course was to use the Amazon registrar, okay, through the Route 53 console, but it's possible for you to use any domain name registrar. So for example, you can use GoDaddy, you can use Google Domains, and so on. And usually, whenever you register a domain with a domain registrar, they will provide you as well with a DNS service to manage your DNS records. So when we registered a DNS name with a host name with Amazon, we had a Route 53 hosted zone to manage our DNS records. But it's possible for you to choose not to use, for example, AWS Route 53 as your DNS records when you have it registered your domain with combination. So pointing to name servers. So okay, so let's clean up what we've done in Route 53 if you wanted to avoid some costs. So the domain name that you've bought, of course, stays in your account, and it will cost you $12 a year if you wanted to renew it, or more if you've bought a more pricey domain name. The domain name itself, so the hosted zone, if you're not using it, you can delete this hosted zone by first emptying all the records. Otherwise, it will cost you 50 cents per month to keep this hosted zone alive, okay? Within it, it does
demonstrate active listening skills. But how can you remember to do this? Well, let me give you a quick tech